We'll proceed in pseudo multivariate calculus. Pseudo multivariate calculus in which we are pursuing the discussion. Pseudo multivariate calculus. Multivariate means independent components are more than one. So that is multivariate calculus. Okay, in pseudo multivariate calculus, the idea is whatever we need to do, we try to find out the pseudo code, the abstraction of the code with a simple case, and that code now we make it extended, make it bigger as per the requirement. Okay, very funny case, very simple case I would take. Okay, I need to calculate work done, energy. I need to calculate work done. There is a force. Okay, so there is a force. What is your force? Force is xi plus yj. This is my force. Xi plus yj. This is the force I am talking. What is xi plus yj? Xi plus yj is the force. This is a vector xi plus yj. Means if y is 0, then it is along x-axis. If x is 0, then it is along y-axis. Consider this is x-axis and this is y-axis. If xi plus yj, if y is 0, then force is along x-axis. If x is 0, then force is along y-axis. Okay, it looks like when x equal to 1, y equal to 1, force is like this. This looks like it is a radial force. So at the center, if I keep the vector, then it will, this is x-axis, this is y-axis. If x is on the minus x-axis, x is minus something and y is 0. This is the force. xi plus yj. Why are you in trouble then? Okay, I want to calculate, this is the force direction, that is radial. Okay, now I want to calculate because of this force. Consider this is electromagnetic force and there is a path like this or there is a path like this. This is well-known equation. There is a path like this. This is x-axis. This is a path. What is equation of your path? Equation of path is function over x, that is fx. Thank you very much. So function over x is your path, right? Yes, function over x is my path. What is your path? That is fx. Function over x. What is fx? That is x square. So this is x square. Now, if this is x square, then this is force. This is x square, then this is force is radial. And consider that I am putting one item here. There is a bolt, iron bolt, that I pierce it into this curve. I believe it makes sense. It is a very, very crucial example. There is a bolt, there is a bolt, there is a nut, and there is a bolt that is with hole. I pierced one bolt here. Now, because of this electromagnetic force, this bolt is going from one location. Consider from origin. If I pierce it at origin, bolt comes here. Because of this electromagnetic force, bolt is shifted from this location to this location. Means the energy required to move a bolt along this path is given by the force, that is xi plus yj. Can someone calculate that how much energy that is imparted by this force to make this bolt move from here to here? Or if bolt is moving from here to here, how much energy this bolt is consuming? This is a big equation, big formula, right? Can someone find what is the work done of a bolt, that is, this is origin, moving from origin to any point which has a kind interception on the x-axis is x. This is x comma y. From 0 comma 0 to any x comma y along a curve, that is function over x, that is x square. How much is the work done that is done on this bolt when force is xi plus yj? Can someone calculate it? Now anyone would say that work done is force dot product with the displacement vector. Force vector dot product with the displacement vector is the work done. Okay, okay, thank you very much. Thank you for the information. That force into displacement vector is the work done. Okay, now force vector is xi plus yj dot displacement vector. What is displacement vector for this? I mean, what is the vector representation of this curve? That is the net work done. Now we came back to the same formula what we did in the past time. So what is the vector representation of a curve? Now if someone remember, then we tried this discussion. We tried this discussion for the finding if this is x-axis, then what is the length of this line from origin to x comma y? That is same as if I represent this line. If I represent this line in a vector, calculating the magnitude of the vector gives me the length of the line. If it is from 0 comma 0 to point x comma y, then this vector is xi plus yj. Okay, magnitude is x square plus y square square root is the length of this line from 0 comma 0 to x comma y. The algorithm is first first try to represent the line through vector and then calculate the magnitude of the vector. Now, for the many times I have described many times. Now, to find the length of this curve, now I have to represent this as a vector. What is the vector for this? Now, for that I take a simple case as a straight line. And what is the vector representation for this is xi plus yj. Same, I am trying to find the length of this line. Length of this line from origin to point x comma y. Okay, rather than this curve, I take a straight line and find the length. Now, what is difference between this and this straight line? For this straight line, everywhere y by x, y by x, y by x, everywhere y by x is constant. Whereas, same thing, take y by x at any point of the x, it will be any point, it will be same value. Whereas in this curve, which is not a straight line, y by x is different everywhere. Here y by x is different. If it is x square, then if x is 10, then y is 100. Y by x is 10. If x is 5, then y is 25. Then y by x is 5. Everywhere y by x is different. So whatever the we are calculating the vector length, that is x vector representation xi plus yj, there y by x should be there. Then that vector will represent this curve also. Then it will become x, I can take outside, it become I plus y by xj, y by xj, and then whole multiplied by x, I plus y by xj, whole multiplied with the x, same thing, xi plus yj. Now here variable y by x is coming into the picture. This is the vector representation of the same vector xi plus yj. Now calculate the magnitude of this. That is 1 plus y by I plus y by xj. That is the vector into some variable, that is x. Magnitude of this is 1 square plus y by x whole square root into x. This will transform into calculus because y is dependent upon x. Y by x numerator is dependent upon denominator, and whole this stuff is dependent upon x. It will go into differentiation and integration both. It will become 1 plus dy by dx whole square root into dx. Now x is from 0 to x. So this is the way. Okay, okay, understood. Thank you very much. Now you were in phase of calculating the energy that a bolt is moving from one location. A bolt is moving from one location 0 comma 0 to x comma y along this line, that is fx function over x, that is x square. Along this line fx, that is function over x, that is function over x, and that is function over x, and that is x square. Okay, in that sense, what force vector dot displacement vector is the net work done. What is force vector? Force vector is xi plus yj. What is displacement vector? Displacement vector is I plus dy by dxj into dx. Make sense? Okay, the displacement vector is along the line, right? A line representation is very well demonstrated as I plus y by xj into x. In calculus form, I plus dy by dxj into dx. Dot product with xi plus yj. I can't believe it. Okay, don't believe it. Okay, I am taking it as a circle. Now this is x-axis. This is x-axis. Hop, hop, hop. This is x-axis. This is x-axis. There is a circle centered at the origin. This is origin. This is x-axis. Then the circle has formula as x square plus y square equal to a square. Y, that is function over x. Y equal to square root of a square minus x square. Y equal to square root of a square minus x square. That is the function. Okay, try your. Now, what is your force? Force is radial. This is center. The force is xi plus yj. In that case, the bolt is moving in a circular fashion. Now, bolt is moving from minus A to A. From here, bolt moved like this. Bolt moved from minus A to A like this. Now force is like this. Can you calculate the work done? Okay, force vector dot product with the line vector. What is this curve vector? Whatever the curve is, it is I plus dy by dxj into dx. That is the curve vector equation. So xi plus yj dot product I plus dy by dxj into dx. Now it will come as what is y? Y is square root of a square minus x square. That is y. Dy by dx is minus x by square root of a square minus x square. So the vector for the curve becomes I plus minus x by square root of a square minus x square j dx whole dx, and this side it is xi plus yj. Why? Since we want along the curve of the circle, I can I can I can substitute y as square root of a square minus x square. Now it is from integrate. Now it is xi plus yj, that is the force. Xi plus square root of a square minus x square j dot product, and in bracket I minus x by square root of a square minus x square j, and then dx. Now xi and I dot product, it becomes x, and square root of a square minus x square dot product with minus x by square root of a square minus x square become minus x. Now it becomes x minus x and then dx, that is 0. There is no work done. Okay, means the path we are taking is a circular path. In this circular path, if force is radial, force is everywhere, it is perpendicular to the path. Means because of this force, if there is a electromagnetic force is there, magnetic force is there. If I keep an iron bolt here, automatically it will not move from here to here, because the path it will take to move, that path is per everywhere, it is perpendicular to the force. So force dot path is 0 because it is 90 degree. So 90 degree dot product is 0. Iron bolt will never move in circular fashion because of the force, that is xi plus yj. Okay, okay, understood, understood. Thank you very much. What about a line? Now I'm changing the line. Instead of the curved line, I have a line that is x square. Now you tell me. Okay, now it is xi plus yj dot product I plus dy by dx, that is 2x. Dy by dx is 2xj, and then outside dx. Now it is x I, it become x. x plus y into 2x. Y is x square. X square into 2x. Now it becomes 2x to the power 3. Now it becomes x plus 2x to the power 3 dx. Okay. Now if someone integrate it, x become x square by 2 and 2x to the power 3 becomes 2x to the power 4 by 4. Okay, x to the power 4 by 2, 2 by 4, 2. This is the net work done, x square by 2 plus x to the power 4 by 2. Make sense? Now, from where to where you want? Now, in this line, I want 0 to x or 0 to 2. Then 2 means 2 square by 2, that is 2, plus 2 to the power 4 by 2 means it will be 2 to the power 3, 8 plus 12. That is the 12. Whatever the unit comes, 12 is the work done. Makes sense? Amazing, mind blowing. Anyway, thank you very much. Can you try something like that? That along a line that is again radial, along the line that is again radial to the circle. Okay, that is same xi plus y. Yeah, same xi plus y. Can you find the work done by the force making a bolt move in a path that is xi plus yj? What you tried? You tried in a circular path, right? Okay, thank you very much. You tried in a circular path. Then what about xi plus yj? In that path I want xi plus x. The path is xi plus yj. Okay, if that is the case, then someone can now try, that is I plus dy by dx, xi plus yj. This is the path along the, so someone can say that xi plus yj is the force dot product with the displacement vector. Now displacement vector is xi plus yj. Displacement vector is xi plus yj. Or so if someone wishes, he can go with whatever we have talked. That is I plus dy by dxj and then dx dot product with xi plus yj. It will become x plus y into dy by dx. Okay, bracket close, dx. Whatever comes, this is what someone is trying. Okay, x plus y dy by dx into dx. Okay, not satisfied, someone can break it. Now it becomes x dx plus y dy. It is x square by 2 plus y square by 2. Okay, okay. Understood, understood. Thank you very much. It is, what about if y is a circular equation? Y is a circular equation. What is your circular equation? Y equal to square root of a square minus x square. Now you try. Okay. Then it is, what came was x plus y into dy by dx, and then outside dx, x plus y dy by dx minus x by square root of a square minus x square. Y equal to square root of a square minus x square, because x square plus y square equal to circle a square. It is the equation of a circle. If it is a equation, if it is a equation of a circle, then x plus y into dy by dx into dx. dy by dx is minus x by square root of a square minus x square. Square root of a square minus x square is y itself. Actually, it is minus xy and into y gone minus x. Okay, I'm sorry. I am, if I am doing something really wrong, we will try it again. Okay. Now idea is okay. Whatever we are trying, y equal to square root of a square minus x square. I believe through that way I am trying again with this side. I plus dy by dxj, and then into dx, if I take y equal to square root of a square minus x square dy by dx, I am trying this vector again. But idea is this vector. Idea is this vector. So I cannot substitute y dy by dx where y equal to square root of a square minus x square, because right now direction of the of the vector along which the bolt would move is also radial every point. So in that sense, in this direction, y is not square root of a square minus x square. Y is square root of a square minus x square when vector is along the line, in circular line. It is a straight line and it is varying like this. In that sense, y by x, we don't know what is relationship between y and x. Looks like that. In that sense, we will break it. So the generic formula will be same: xi plus yj dot product in braces I plus y I plus dy by dx j, and then dx. We will break it. Or if I go along, it will be x plus y into dy by dx, and then outside dx. If break it, then it will x dx plus y dy. X square by 2 plus y square by 2. X square by 2 plus y square by 2. That is the work done. Okay, now x square by 2 plus y square by 2. Okay, that is the work done. Now someone can substitute y and x whatever he wants. If I talk in kind of circular fashion, in polar coordinate, if I have a radius like this, if I have a radius like this, then if this is a vector that is moving like this, then what is the representation of this vector in polar coordinate system? Then xi plus yj, I can take x equal to a cos theta and y equal to a sin theta. A cos theta and y equal to a sin theta. Okay, if that is the case, then it becomes whatever we calculated x square by 2 plus y square by 2, then it becomes a by a square by 2 cos square theta and y by 2 a square by 2 sin square theta. It will come a the work done will come at 2a square by 2 a square. A square means radius square, means force and displacement, they are in same direction, they will be exactly multiplied. A square means radius square. This is what we wanted. I believe it is all right now. Anyway, so this is the concept that someone can really try in his life. Okay, so this is how we tackle any calculus problem: is try to find the, if it is vector, then try to find a vector representation of a straight line the way I am carrying. Okay, then like what we did is that force vector dot product with the length vector. This is what we did. If I am trying to calculate force along any curve, then curve is represented by length vector. That is I plus y by xj, and then whole multiplied with the x, or I plus dy by dxj whole multiplied the dx. This is called length vector. If I multiply force, if I do dot product of force vector with the length vector, then I get the force into length, that is the work done. If I calculate magnitude of the length vector, then I get the length of the curve. Similarly, if someone is trying to calculate velocity vector dot product with the area vector, he gets the flux that we have seen in past time. Flux means if there is a liquid that is passing through this surface. Okay, liquid has a velocity as v vector, because liquid has a direction. If liquid is passing through the surface, then how much volume that is coming out of the surface? That is velocity into this area, or velocity vector dot product with the area vector. Area vector is perpendicular to this surface. That is called area vector. Now idea is first to calculate, we calculated length vector. How to calculate area vector? Now for that we have given, means idea is go with the, anyone should start with the minimal thing, simplest thing, convert it to calculus and then proceed. Convert into calculus means division will transform into differentiation, and multiplication will transform into integration. Anyway, means velocity vector dot product with the area vector is the net flux that comes out, net volume that comes out of a surface when a liquid is passing, it has velocity as velocity vector and surface as surface vector. Try to find surface vector in terms of calculus and then do the dot product. We have calculated surface vector earlier also. So surface vector, if I'm trying to calculate, like if this is xy plane, if this is xy plane and this is any surface here, what is the surface vector? This surface vector is like this. If it is a flat, we will take flat only right now. That is the simplest, right? That is the mode of algorithm. If this is flat, then this is surface vector. This is surface vector. 90 degree to the surface, surface vector. Okay, surface vector, if I am trying to calculate, then I cut this plane into xz plane and yz plane. In xz plane, if I cut this into xz plane, then this is a flat surface. It is tilted like this. If I cut in xz plane, then only one line will remain. If I just cut it xz plane and see the essence of this surface, there will be one line like this from my side. If this is like this, and if I cut in yz plane, there will be a line like this. Okay, what is the surface area of this? This vector, this vector cross product with this vector. If there is a rectangular region or parallelogram, whatever it is, idea is that both sides should be parallel to each other. In that case, if I take a vector from one side and a vector from other side, if I do cross product of these two, then I get the area vector. Okay, what is the vector equation of this side? This is in xz plane. What is the vector representation of this side? What in simple manner? What is vector representation of this side? Just do the cross product. Vector representation of this line that is in xz plane will have x and z component. Y will not be there. Okay, because there is variation in x and there is variation in z. Since it is in xz plane, there is no variation in y. The other side of this, it is in yz plane, then there is no variation of x. It is in exactly in yz plane. Y variation is there, z variation is there. So the equation of this line is xi plus zk. Equation of this line is yj plus zk. If I take this into a length vector, right now it is a straight line vector. Any curve length vector, then it will transform into 1 plus z by x k into x, and that will be j plus z by y into y. Cross product of these two will give the area vector. Why I am discussing this? Consider that I don't want flux. Flux is velocity vector dot product with the area vector. What is area vector now? Area vector is I plus z by x k into x cross product j plus z by y k y. If someone does this cross product, it becomes minus z by xi minus z by yj plus k and whole into x into y. This much it will come. If someone transform into calculus, then it will become minus dz by dxi minus dz by dyj plus k, and then that side it will become d of x and y. Okay, that much it will come. This is called area vector. This is called area vector. Now someone has to multiply this with the velocity vector. Suppose the liquid is flowing only in I direction along the x-axis. Then velocity vector is vi. It doesn't have j and k. Then whatever the velocity vector is considered, it is x square I. That is the velocity vector. Means as it goes along x-axis, velocity of the liquid is growing. In that sense, what is the volume that is coming out of the surface? xi dot product with minus dz by dxi minus dz by dyj plus k d of xy. Now in that sense, dx dy. Now that is the area vector. Now xi is an I vector will remain, j and k will go away because of the dot product. Now it becomes x square minus x square dz by dx dy, where it will be the the limit will be what is the area through which it is passing through. Consider it is passing through a surface, a spherical area. Consider it is passing through a spherical area. Consider it is passing through a conical area. Consider it is passing through a paraboloid area. Make sense? Paraboloid is like this. If this is if this is xy plane, then paraboloid will be like a lotus temple, like this. This is paraboloid. This portion will be origin, and this is paraboloid. This is conical. Okay, this is spherical. If it is passing through spherical, this velocity, that is x square I, then it becomes like x minus x square dz by dx, d of xy. Now, what is the surface through which we are thinking that it will pass through? That is the limit for x and y. Okay, that someone has to place the limit, but what it will become, that I'll talk now. Minus x square dz by dx, z is the square root of a square minus x square minus y square in case of a sphere. Then it becomes minus x square, and then it becomes dz by dx would become minus x, again minus x by square root of a square minus x square minus y square, minus gone. It becomes x to the power 3, x to the power 3 by square root of a square minus x square minus y square dx dy. Go and calculate. Okay, if it is a paraboloid, then z equal to x square plus y square. Dz by dx is 2x. 2x minus dz by dx means minus 2x, and this is velocity x square minus 2x to the power 3 dx dy. That is the for the paraboloid. The dy will be y, whatever y you are taking for the paraboloid, and whatever x and y someone is taking. If someone is taking circular region in the paraboloid, whatever he has to fulfill. Same for the cone or whatever. The main idea of this discussion is, if I don't go with the dot product, we already have length vector and area vector. If I calculate the magnitude of length vector, it gives length. If I calculate the magnitude of area vector, just magnitude of area vector, not the dot product with the velocity vector to calculate the flux. Just if I have, what is the area vector? Area vector is minus dz by dxi minus dz by dyj plus k d of xy. Then limit. This is area vector. If I just calculate this magnitude of this area vector, will it give really will it give the area? It will give the area because it is area vector. Okay, if I have a line vector, that is I plus dz by dxj into dx, if I calculate the magnitude of this, will it give the length? It will give the length. If I have a volume vector, if someone calculates the volume vector, that is height dot area vector, height vector dot area vector, that is called volume vector. If someone calculates the magnitude of volume vector, will it give the volume? It will give the volume. Certainly. That is called volume vector. Okay, so we will take some example, or someone can try. Actually, we tried volume vector to calculate the volume of a sphere in spherical coordinate system in the past video, and it came as r square sine phi dr d theta d phi. If someone remembers it. That is volume vector. Or someone can calculate with area vector. Someone can calculate the surface area of anything. Mind blowing, amazing. Please do not mind supporting us. Plus 91 is the India code. Country code 9483160610 is the telephone number. 9483160610 is the telephone number. Plus 91 is the India country code.